we will hit the press switch, and the happy birthday song will play, but the volume of the sound might be reduced. That is because the lamp is in series with the speaker, and therefore the lamp reduces the voltage across the latter component, the speaker. I'm going to turn on the press switch, and the music will play, and then I will remove the LED from the circuit, and you'll notice that the volume of the sound does not change. That's because the LED is in parallel in this circuit, not in series with the speaker, and so the removal of the LED does not affect the current flowing through the speaker. Project 92 is pretty interesting. It is called Mr. Magnet's Birthday, and we will have the reed switch in place, and we will turn on the circuit. Nothing happens, but then we will place the magnet on the reed switch. Now we could pretend that the magnet is attending its own birthday party, but let's say the magnet leaves while the happy birthday song is playing. The birthday song stops because, logically, what's the point of playing the happy birthday song if the person who it is playing for, whose birthday is being celebrated, is not actually there? But when the birthday guest returns, the song can play again. And I'll let play until the end. And now it loops too, in this particular instance. The magnet must be really receiving a lot of birthday wishes. For 93, Birthday Party Disc Jockey, I will turn on the press switch. Now we're going to leave the magnet on the reed switch this time, and I will hit the touchpad. The happy birthday song plays right from the beginning. You could pretend that a disc jockey, a DJ, is playing a birthday rap song and is repeating it from the beginning or from a certain point over and over again. I am going to turn on the press switch and watch the lamp. The lamp flickers gently, as if it is a candle in a pleasant breeze. This circuit simulates just that, and you can pretend that you are out on the deck or patio outside, especially at the beach on a nice, cool, pleasant evening, and you light a candle, and it just flickers quietly in the wind. With the press switch on, I am going to hold my finger against the touch plate, and the lamp is going to flash very quickly. It may be hard to notice with my phone, but you probably can tell that it's flashing quickly. It would be like I was sending a very quick Morse code and someone else was receiving it. This is only a simulation and not a real code. I'm going to turn on the press switch. The lamp comes on and flickers gently, but then I'm going to tap the touch plate and the lamp will go off. Now this project is called Automated Code, and I am going to tap the touch plate repeatedly with my finger, and I can pretend that I'm sending a message in Morse code. The short taps resemble dots, while the long taps resemble dashes in the Morse code system. And you could pretend that you are communicating with somebody in the dark. Like if you don't want to alert others around you, this could be like a good old-fashioned way to talk to somebody without actually speaking. I am going to turn on the press switch, the lamp lights, but then I'm going to turn it off by touching the touch plate once. Now with the lamp off, I am going to place the magnet on the reed switch, and this candle will light. you could pretend that the magnet is like a match, and that when you put it on the circuit, on the pretend candle, it lights the candle, even though technically you're not placing the magnet on the lamp. So you could pretend that the reed switch is a special igniter for the candle. For this project, 2-channel monitor, I am going to turn on the press switch, and the lamp will flicker slowly as if it was a Morse code signal that was being monitored. If I was to hold down the momentary switch, it may be hard to notice, but the lamp flickers a lot more quickly, as if the Morse code signal was being changed. Now, this is similar to what a technician working for the FBI or CIA, for instance, may see when they change the channel that they are monitoring. For this circuit, I am going to turn on the press switch, and the lamp begins to flicker. Now I am going to tap the touch plate repeatedly with my finger, and carefully watch the brightness and rate at which the lamp flickers. Right now it's flickering a lot faster, but now it's flickering slower. This is simulating the different transmission speeds of a Morse code message. And the brightness of the lamp will also indicate the strength of the signal. If the lamp is dim, that means that the signal is not very strong, but if it's bright, that means it is fairly strong.